So now let's go to naming of bicyclos and spiros. Let's start with bicyclos. So from the name bicyclos, what does bicyclo mean? The word bi means two, then cyclos, the cyclic compound. What are cyclic compounds? Cyclic compounds are those compounds that form a closed loop. While we were treating the classification of organic compound, we mentioned cyclos. For instance, the cyclopropane, the cyclohexane, they are cyclic. They look like it's a shape, like a pentagon, hexagon, like polygons generally. So let's assume we have this shape. You should know this shape. Carbon, carbon, carbon. Then there will be two hydrogen. There is C3H6. It's looking like a thing, but then it is single bond of through. So that is cyclo. It's looking like propene rather. Propene, yes, C3H6, but it is single bond of through. Do you understand? So that makes it cyclopropane. Do you understand? So we already explained this in the previous classes. I think that should be organic chemistry, introduction to organic chemistry. You can see that in that video. So this is cyclopropane, of course we know. And let's add this to. I'm not saying this is how it formed though, but I just want to explain the word bicyclo to you. So this is cyclopropane plus cyclohexane. If these two comes together, it becomes a bicyclo. Two cyclic compounds. So that is what the word bicyclo comes by. So let's look at if we add them together. Let me just put this place, this AB. Let me link it to this place. Let me call it AB. So I want to fix this one. Don't look at this one is longer than this one. The way I do it, the same length is what I want to use. So it means we'll have something like this. This AB place. This AB. Let me call it A. Okay. So I have this. No. Okay. This part. So I have this part. Okay. And I have this one, and I have this one. Okay, and I have this one. So this is the AB you have seen here. So this is the cyclohexane and this is cyclopropane joined together. So how do we name this? So when you want to name cyclo compounds, let me draw it very well. So just go by this. Sorry. So this. So let's go with this. So let's just look at this way. So when you want to name bicyclo compounds, what you need to do is look at the point where they meet. Where the two cyclos meet. That's this point. And this place as well. That's where they meet. So you can just call it maybe one, or let's call it A or edge. That should be H. That's where they met. So you can call it H or call it A. Let's use A. A instead. A. Now, you want to get the number of, how many pathways you have. There are 3 paths to which you can move from A to the second A. Look at the first part. You can move this way. Bam. You have arrived at A. Another part is you can, move this straight line here. Another part is you can come here. So there are 3 different pathways: the left one, the middle one, and the right one. So in naming of bicyclo, we look for, you get the number of steps you need to take for every of these 3 pathways. Then you arrange it in descending order. That is from the highest amount of steps to the least step you need to take. Now let's look at where can you get what pathway would give you the highest amount of steps. Obviously that's this one on the left, right? So let's go. You won't start from the A. You're going to count other corners aside the corners, where they meet. So, corner 1, corner 2, corner 3, corner 4 before you get here. So, you have 4 steps here before you move from A to A. For this one, you don't have any corner. That is, you don't have any edge. It's just a straight. There is no branching. So, you are not branching anywhere. So, that gives you 0 for this pathway. For this one, you have just one corner. That is this place. One corner before you get back. Do you understand? So this is what I meant by corner. So let's assume you are here and you want to get here. You don't count this and this. You count this corner. Corner 1, corner 2, corner 3. 1, 2, 3, 4. So that is how we are going by. So if you have just a line like this, so there is no corner. It's just a straight pathway. So 0. Do you understand? For this one, this pathway is just one corner. Do we get that? So now let's name it. So you say this is a bicyclo. The bicyclo. It is a bicyclo. Into the square bracket. The highest, steps is 4 dots followed by 1. Of course, 0 should be the least number of steps. Bicyclo 4.1.0. Then you want to name the whole compound. So you have to count the total number of carbon atoms you have. Let's count the total number of carbon atoms. So permit me to clean this 401 and this A, so that it won't confuse us. So how many number of carbon atoms do we have? Let's start from this T. I have 1, I have 2, I have 3, I have 4, I have 5. Every corner in shapes like this represent the carbon atom. So I have 6, I have 7. So those are the total number of corners you have, and those are the total number of carbon atoms you have. So for 7 carbon atoms, that's what earth, right? 8 should be oct. So this is earth. So bicyclo 4.1.0 heptane. So this is the naming, or this is the name for this bicyclo. Now, what if you have substituent? Substituent means aside your chain, your family, your chain, any other element you see that is not hydrogen. That's that's your substituent. Now let's assume we have this substituent. Let's say we have okay, let's use this same shape, or let's use another one. I feel this same one will be okay since you already understand how we name this. So let's use this same. So another thing I want to say is this your bicyclo. It's not always in this form. I want to draw this in another way. Instead of putting this one in outside, I want to bring it inside. I want to close it. So I want to fold it inside. Look at still my A. So it's still the same thing and it's still the same name, because the first step 1, 2, 3, 4. This is the step. So count the corner 1, 2, 3, 4. The next one 1. The last one 0. It's still the same name. Do you understand? So whether it's folded in or it is folded out, it's still bicyclo. So far you have 2 cyclos. You can trace 2 cyclos out of it. You understand? They are fused together. So bicyclo is just 2 cyclos fused together. So this is still the same name, but let's add a substituent. Let's add this substituent. Let's add chlorine here. Let's say there is a chlorine attached to this one. And let's say there is a CH3 attached to this one. Let's say there is a CH3 attached to this one. So what would you have named this? So to name this now, let's draw it. Should be big this time. Then you have this. So naming this bicyclo, still the same step. Where did they meet? Here. Yes. So just call this place the A, or let's call it 1 now. Since you already know how we name it, you count the total number of steps from the highest 1, 2, 3, 4. 1 and 0 for this one. So 4.1.0. Then you call everything that is heptane. We're just concerned about the substituent now. Now to name the substituent, this is where you have a work to do. You want to name the substituent, then you ask yourself, if I want to name the substituent, if I call this carbon number 1, I have to go this way. So 2, 3, 4, 5, 6, then 7. That's how you got about 7. You have to, when you take a part, you have to go around it and you take the highest step. You understand? Like the highest, the pathway that has the highest number of steps. That is what you have to first take before you apportion numbers to others. So taking that pathway now, then I'm done. I go to the next one, 7. The next highest, and that's this one, 7. This one doesn't even have any corner, so I don't need to put anything. But let's assume this one has 3 corners. I have to first name these 3 corners here before I go to this one that has either 2 corners or 1 corner. So you name them from the part with the highest number of steps to the next part, with the higher number of steps, to the next part that has the lowest number of steps. So now after naming this, you ask yourself, there's a decision here. You could have called this one and you could have called this one. because both of them, there is no head, there is no tail, unless you decide which one is the head or which one is the tail. So this one, I have decided that this should be my head. Now let me look at what my decision will bring about. Your decision will not affect this numbering. You know, you are not using the number of carbon, you are not using the specific number of carbon, you are just using how many of it. So your numbering will not affect this name. Don't be afraid. It's just your subsequent that will be affected. You've already named this one by that first step we did, Bicyclo 4.1.0 heptane. So you can now clean everything you have used to name this one and now come back to reality. Do you understand? Or from one side you might have done it. Don't worry, when we take examples, you will get it. Now I want to name the constituent, the substituent rather. Now, this is my decision of calling this one the first instead of this down. Let's see what it will yield. With this one, I am having my the positions of my substituent to be 5-methyl. So methyl is in position number 5. That is carbon number 5. Then chlorine is in carbon number 7. 7-chloro. That was what my decision, gave out. Now let me change it. What if this one wasn't the head? What if this was the head? Number 1. Now taking the parts again. You go with the part with the longest, steps first. So 1, this would have been 2, 3, 4, 5, 6. Still go back to 7. Do you understand? Now, what would the position, would have been? It would have been 1-methyl. Do you understand? 2-methyl rather. 2-methyl and 7-chloro. So which one? 5 plus 7 gives you 12. 2 plus 7 gives you 9. So the list is what we do go for. The journey where you spend the least, the pathway where you spend the least amount of money for TIF here is where you trade in, and that's this pathway. And it's calling this other end the first position because it is closer to your substituent. Do you understand? At the end of the day, the accumulation of the position of substituent gives you the least number. Do you get? So that makes it that we are going with this one as the first, not this one. You can always have 2 first, either where the first met or the second place where they met. Do you get? So none is the first to say. It depends on what you call it from your decision, your evaluation, and decision you come you arrive at. So this one goes with methyl and chloro. Which one comes first alphabetically? C, chloro, M, methyl. So chloro comes first. Position of chloro: 7 chloro, 2 methyl, Bicyclo 4.1.0 heptane. Are we good to go? So this is the second question I want us to work on. Which one is the first? Let's call this the first. So the second exercise I want us to work on. So this is the Bicyclo. How do you need a Bicyclo? First one is a cyclo. If you remove this inside one, you have a cyclo. If you remove this outer frame, you have a cyclo as well. So normally, if this one is not there to be 1, 2, 3, 4, 5, 6, that will be cyclohexane. If this outer one is not there, 1, 2, 3, 4, 5, that will be cyclopentane. Do you understand? So, but now they are fused together. Let's go. So how do you name it? The first thing in cyclo is where do they meet? The 2 cyclos. This is where they are linked up. This here. That is the 2 polygons. That's the English. Yes. The 2 polygons you have convex polygon. Yes, convex polygon. Because this is also a polygon, but it is not a convex polygon. I think the concave polygon, how do they call it? Yes, because look at the shape now. It's not there. So this is the polygon. So this is the head. And this also, we can say is the head or the tail. Let me just call it H. Any of these 2 can be 1. It depends on your substituent. You understand? But let's still leave that. Now let's just go to naming the Bicyclo first before we attend to the substituent. It has a substituent, of course. That's C2H5. That's 18. But let's name it first. Naming it, start with Bicyclo. Your square bracket. Then you count the number of steps in each pathway. You don't count the head and the head, or the head and the tail, where they meet. You don't count it, remember. So what part do you think? In fact, you don't need to think. Just count the number of steps first. Then for this pathway, you don't count this place. So it starts here. 1, 2, 3. Then you are there. So it's 3. Just put, I have 3 somewhere. Then for this outside one, how many? For this pathway, or let's start with the middle one. For this middle one, so how many do you have? 1, 2. Are we good to go? So that's just 2. So you don't count this place where you are coming from, where you are going. You don't count. You count the corners in between that journey. So just these 2 and 2. So you have 2. Then for this one, this pathway, you have 1. I'm good to go. So that is 1. So 3, 2, 1. So you can just write it outside and you now arrange it from the highest to lowest. That is in descending order. So you have 3.2.1. Then the next is you now count the total number of carbon atoms that is forming all this. 1, 2, 3, 4, 5, 6, 7, 8. 8 in total. So 8 should be oct, right? So octane. Bicyclo 3.2.1 octane. Are we good to go? Now to name this substituent, you definitely know that now you need to pick which one is your number 1 between those 2 heads. Now if you pick this as number 1, are we good to go? Then you pick number 1. Then you travel in the path with the highest step first, and that's this pathway. Then you now go to the number of the path within the one that has the higher steps again. I mean from the highest steps to the one that follows in line, the one that follows in line. You understand? That is how you have to count it. You cannot say 1, 2, 3. You now come to this one. No, the one that has the highest step. It does not mean whether it is the one inside or the one outside. No, it can be anywhere. So far it is one carrying the number of steps. Look at which one has the higher number of steps. This is 3, right? Followed by 2. So you go to that one that has 3 steps first before you go to the one that has 2 steps. Before you go to the one that has 1 step. So I'm not saying because that one is outside here, I have to come and count it first before inside. No. Step. So 1, 2, 3, 4, then 5. You count it. Then you go to the one that has the next step. So this is 6, 7. That is, you have to count them. Count each pathway from head to tail. From head to tail. From head to tail. So for this first one, this is the head that I've called 1 to tail. It stops. So the next one, you have already called the head something. So just continue with number 6, 7. You don't need to name the tail again because it already has a number. Then to this one, the head and the tail has been fixed. Just call it after 7 is 8. Are we good to go? So to name this now, it is 8. Now, would it have changed if I name this other head as position number 1? So 1. Then once this is 1 head, this will be the tail. So 1, 2, 3, 4, 5, 6, 7, 8. Still won't change because that C2H5 is in that last, so just 8 and 3. So that is 8 and 3. So one last question on Bicyclo, then that's all. So the last question on Bicyclo. Now this I want to set up something to some extent. Okay, so this will be the third and last question on our Bicyclo. So for this, you already know what we do. Where do they meet? Here, here, and here. So let's first name the Bicyclo. So naming the Bicyclo, say Bicyclo. Okay, of course this place will not contain, so let's manage. So Bicyclo. Okay, the position 1. This is your head or your head tail, whichever one you want to design. So we don't count it. You count the parts to get the part that leads to it. So here 1, 2, 3, 4. You have 4 inside here. You have 1, 2 here. You have 1, 2, 3, 4 before you get to it. So 4, 4, 2. I'm good to go. So just 4.4. From highest to lowest. So 4, 4, 2. Now your substituent. Okay, 4, 4, 2. Then let's name it the whole compound. Don't say 4 plus 2 plus 4. That's 10. No, you are wrong. You have to count the carbon atoms because you didn't count the head and the tail when we were counting the 4, 4, 2. So let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Another way you can get it is, since this is 4, 4, 2 plus the 2 corners for head you do not count, or head tail that you do not count. So that's 12. So Bicyclo 4.4.2, what would 12 carbon atom be? After decane, on decane, dodecane. So that's dodecane. So Bicyclo 4.4.2 dodecane. Now the substituent, naming the substituent, you can either call this 1 or this 1. So but let's first call this 1 and let's see what it will give. 1, the longest pathway, the pathway that has the longest number of steps, either this or this. So which do you want to go with? If you go with this 2, 3, 4, 5, 6, the next one, because this is the next pathway that has the higher number of steps, that's 4 as well. 7, 8, okay, this is 6, so you cannot jump, you have to continue. 7, 8, 9, 10. Then now move to this one. 11, 12. Are we good to go? So if you name it this way, it means you would have 5, 10, 8. That will be your position. 5, 10, 8. 5 for methyl, 10 for methyl, 8 for chloro. That is what you would have. But let's go this other way. You have gone as, both of them has 4, 4. So you can either go with the left to right or right to left, since it's 4, 4. So you can go with this 2, 3. Still this one has 1. No, I can go with this because it is 4, 4. So 2, 3, 4, 5, 6. Then the other 4, 7, 8, 9, 10, 11, 12. So this would have been 2 methyl, 4 chloro. So 4 chloro, 2 methyl, 7 methyl. Another way you could have gone is making this one 1 now. So this one has different positioning. Why? Because you have 4, 4. So you can take any of the cyclos on the left and right first. So for this one, 1, 2, 3, 4, 5, 6, 7, 8. There's a mistake somewhere. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this one would have been 3. It would have been 3 chloro, 5 methyl, 10 methyl. Another one is to go this way. 1, 2, 3. So this one will be obviously too large because 2, 3, 4, 5, 6, 7. 2 plus 7, 8, 9. 2 plus 7 plus 9. That will be 279. So that will be much as well. So let's see which one is least. 15 plus 8, 23. 2 plus 4, 6. 6 plus 7, 13. 3 plus 5, 8. 8 plus 10, 18. So we definitely know this one wins. This middle one. Do you still remember how we traveled to get this middle one? So this was how we traveled to get this middle one. So this was the travel to get this middle one. It was calling this one the first one, then this second, third, fourth, fifth, sixth. And when we are done, we move to the next, part 2 with the higher number of 7, 8, 9, 10, 11, 12. So this was how we got, this one. That's the least one. So arranging alphabetically order, C alphabetically, still comes before M. So that makes it 4 chloro. So pardon me, there's no too many spaces. So 4 chloro. Then we have 2 7-dimethyl. Then you now have your Bicyclo 442. Do the king. So that is the naming of this compound. So now to Spiro compounds. How do we go about Spiro compounds? Spiro compounds are like they are still bicyclos, 2 cyclos, but this time they are not fused at 2 different edges. They are just fused at the corner. So in Spiro compounds, that is where you see shapes like this. Don't mind my drawing. I'm hilarious since we started this course. So this, then you can have something like this. So this is a Spiro compound. So you can see that unlike Bicyclo, you just have a meeting point here. So just the connection. And there's something about Spiro, you don't label one side first, another. No, it is continuous. Once you pick a point, you must go through and you must not pass through that point again. Do you understand? So for Spiro now, let's assume you start from you can't start here, because if you start here and you go like this, you have to pass here again. So you have to start from maybe somewhere here. So that once you go like this, you can go inside, or you start from somewhere here, you can go like this, or you start from somewhere here and you can go like this, or you start from somewhere here and you can go like this, so that you don't pass a particular point 2 times. Now this is another rule about Spiro. Spiro, you look at the compound, you look at the shape, the cyclo with the least number of steps in it. That is where you are starting your calculation from. The cyclo with the least number of steps. So let's go. Let's count the steps. this is their point, you won't count that point. So let's go. How many steps will you take to get back to this starting point? This is the starting point. So let's go 1, 2, 3, 4, 5. For this you have 5. For this you won't count the starting point. That's the starting point, that's the end point. So 1, 2, 3, 4. For this you have 4. So which one is the least? That's the 4. So if you have to name this now, you say you have Spiro. Now the labeling will be in ascending order. Unlike Bicyclo that is descending order, highest number to lowest. So this one ascending order. This is 4, this is 5. So you go with 4, 4.5. So Spiro 4.5. Then you name the whole compound. 1. You count number of what do you call it? Corners you have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So Spiro 4.5 again. So this is it. Let's assume you have a substituent. Have you seen this? Now let me change something here. Let's assume you have a substituent at this position. So you do not really need this numbering because you don't have a substituent. So you just need to count the total number of carbon atoms. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or just add this together. 4 plus 5, 9. Plus this corner, which is their starting and the end point that you didn't count. If it is Bicyclo, if you add them together, we don't add 2 because they meet at the top and they meet beneath. But this one just 1 because that's where they start and that's where they meet. So 4 plus 5, 9, 9 plus 1, 10. So it's still the same thing. Now let's assume I have a substituent here. Here. Let's add chloro here. Let's add chloro here. Chloro here. Now, what would have been the name of this compound? First, your family or the main compound that is Spiro 4.5 decane. The substituent doesn't change anything about the real name. Now let's name what the substituent is. So I told you that you deal with that cyclo with the least number of steps first. That is this one. The least number of steps first. That is one that has 4. I don't we have 3, 4. You deal with that one that has 3 first. I don't you have 6, 7. You deal with the one that has 6. Do you understand first? So it means we are dealing with this 4th one first. Now let's see what direction can we go, to get the least number of position for our substituent. If you call this, you can't start from here. You have to pick either here or here, so that once you go, you won't pass here twice, or you pick here. So either you go clockwise or you go anti-clockwise. So this one, the corners decide it where you can start from, either this corner or this corner. Those are the 2 corners that decide it the most for this small number of steps, cyclo. So if you go with this one, it will be 1, 2, 3, 4. But if you go with this one, it will be 1. So which one will give you the least number of steps for this cyclo alone? So it means calling this one 1 give you the least number of steps. It makes your substituent, that is chlorine, your chloro, it makes it on position number 1. Unlike if you had gone for it here, it would have been 2, 3, 4, position number 4, and that's not nice. So 1, 2, 3, 4. Then this is 5. Now let's look at, we can either call this 6 or this 6. We can call this 6 or this 6. So which one would be right? If you call this 6, okay, for the second question under Spiro now, how do we go about it? I already told you that. It's already Spiro. Why? Because just a single point, of meeting, and you have 2 cyclic compounds. So what do we do? You look at the cyclos, which one has the least, number of steps? 1, 2, 3, 4, 5. You won't count the meeting point. I hope you remember. 1, 2, 3. So 3, 5. Just put it in. 3 steps aside the meeting point. 5 corners aside the meeting point. So definitely, naming the Spiro, you have Spiro 3, 5, 3.5. Then the shortcut to know the total number of carbon atoms is 5 plus 3, 9, 9 plus this one. And 5 plus 3, 8, 8 plus this one, 9. Or better, count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is no name. So Spiro 3.5 no name. Now, time for the substituent. You know that you have to name the substituent on this side with the fewer number of steps first. That's what we do. You give attention to the fewer number of step cyclo first before you go to the next one. So now let's see what route would have been the lowest. Okay, we can't start our position number 1 from this meeting point. You have to start from either this or this. So if you start from this 1, this would have been 2, 3. If you start this as 1, this would have been 1, 2. So 2 plus 3, 5. 1 plus 2, 3. So this would take the lowest number of steps to apportion this subsequent. So it means let's call this 1. Do you understand? So this is 1, this is 2, then this is 3, then this is 4, the meeting point. Now, so it means we are going anti-clockwise. Now let's decide for this one. If we had gone, this way, it would have been, let's go this way, 5, 6. So you have on 5, this would have been 5, 6, 7, 8, 2 on 8, 8, 5, 8, 8, 9. But if you had gone this way, let's see, it would have been 5, 6, 6, 6, 7, 8, 9. Now let's see which one has the lowest summation at the end of the sum. 5 plus 8, that is 13. 13 plus 8, 21. 6 plus 6, 12. 12 plus 9, 21. So let me ask you, 21, 21. Which are we going with? Okay, pick. Of course, we are going with this. Why? Because even when you have the same sum, then you have to look at the way it will be written. Which one comes first? 5 and 6. The first digit in these two is 5. Do you understand? So 5 comes before 6. So we are going to go with this 5, 6. Since they have the same number, but I mean this is 20. I mean this is 20. So you are going with 20 instead, regardless of whether 5 or 6. But since they are the same thing, you still need a reason to to make one step down. So you have them. If I arrange your which number comes? I mean you have 169. You understand? It's still 21 cents at the end of the day, or 1 wins over 5. You get. So I'm going with 5, 8, 8, and making this 5, 6, 7, 8, 9. So now let's list every of the subsequent we have. We have ethyl on position number 2. We have methyl on position number 1. Position number 8, 8. We have chlorine, that's chloro, on position number 5. So alphabetical order, C comes before E, comes before M. So first one, second one, third one. So now let's name it. First one is chloro, 5 chloro, 2 ethyl, 1 8 8 trimethyl. Then the family or the compound, name itself, methyl, Spiro, 3.5 nonane. So thank you for listening. Wishing you all the best.